All right, there's two methods for solving systems of equations that you guys have learned. You have learned elimination and substitution. Elimination is the one where you line up the x's, the y's, and the constant, and then you get one of the coefficients of one of the variables to be the exact opposite of the other one, and you cancel it out and solve. You guys also learned substitution, where you solve one equation for one particular variable and then substitute it into the other one. All right, I understand that some of us like one better than the other. If I could, I would do every single equation with elimination. It's just easier to me. But there's some instances where you have to use substitution. So we're going to just go over it again today. You will see problems with fractions. You will see problems with decimals, but I'll show you how to eliminate both of those things. So you just work with whole numbers. And we will have word problems. They're going to be fairly basic, but you guys will have word problems. So follow along with me as we go through this. The beauty of solving equations when you get x equals and y equals is you can do what with your answer? You can plug it back in. You can plug it back in and check. You can say, hey, look, I plugged it into the first and second equation and both of them are true, which is what you need to do because sometimes you get an answer where it works in one and not the other. That sort of thing. So in a situation like example 1, super basic, you guys, if it says solve using substitution, then you figure out which equation you want to manipulate and which variable you want to choose to solve for. I'm just going to look at the first equation and say I'm going to solve for x. I want to get x by itself in this first equation. So if I want to get x all by itself, what would I do with y? Subtract the y. Perfect. So if I subtract y, do you guys agree that this says x equals 4 minus y? Correct? Now you would take this in substitution. You would take this value and plug it in right here. So when I rewrite this, it becomes 4 minus y. Then what? Minus y equals 2. Perfect. So now we solve. Combine like terms. What's negative y and negative y? Sure. So 4 minus 2y equals 2. Then what? Minus 4 from both sides. So negative 2y equals negative 2. Then what? Divide by negative 2 and y equals 1. Now that I found out what y equals, how do I find out what x equals? You plug it in. Does it matter which equation I plug it back into? No. I'm just going to use the top one. So x plus 1 equals 4. Subtract 1 from both sides, and x equals 3. All right, we just solved this system of equations, and we found out the x value and the y value. Do I leave my answer just like that? No. How do I need to write it? As an ordered pair, 3, 1. Please, you have to write your answer as an ordered pair. What can you do with this ordered pair now that says, oh, good, I got the right answer? You can plug it back in. You could graph both of those equations. What happens when you graph both of those equations? They do what? At 3, 1. They intersect. Okay, so we write our answer as an ordered pair. So on WebAssign or on a quiz, if you're given a system of equations and then an ordered pair and it says, is this a solution? How would you prove that it is a solution? You plug it in. It would make the equations true. If you graph these two lines would intersect one time at the point 3, 1. You guys remember this? Good. All right, look at the next one. All right, this is a little more complicated. Why is this one a little more complicated? There's an x squared, okay? This is not linear anymore. That's okay. This is the type situation where you guys couldn't use elimination. If this x squared wasn't there, absolutely, we could eliminate. We just multiply one of either the top or the bottom by negative 1, right? And then our y's would cancel out. But we can't do that. So this is why we have to remember and learn how to do substitution. Which equation, the top one or the bottom one, would be easier to solve for one specific variable? The bottom. And which one of those variables would be easier to solve for? Y. How come? Because you get all x's, and also it doesn't have a what? Doesn't have a number in front. Doesn't have a coefficient. We want to try and use the easiest one possible. Now, guys, you're going to make silly mistakes on signs. So just make sure this is why I highlight so you guys can see. We need to get rid of the 2x, right? So subtract the 2x. This says negative y equals negative 1 minus 2x. I want it to be positive y. Divide or multiply everything by negative 1. So this becomes y equals, both the negative 1 and the negative 2x become positive, right? Yeah. So are you guys okay if I write 2x plus 1? Yeah. Okay, I like the way it looks better. So I'm going to now take this value, and I'm going to plug it in right here. But notice what's in front of this. What's in front of that y? A minus sign. So watch what I do when I write this in. X squared plus 4x minus, how come I'm putting this value in parentheses? Good. You have to distribute that negative. Just be careful. If it was just one term, you wouldn't have to put it in parentheses. But since there's a minus, if there was a plus, it doesn't matter. But since there's a minus there, we have to make sure, you good? Okay, you have to make sure that you distribute. So this, when I combine like terms, I have x squared plus 4x. This becomes minus 2x minus 1 equals 7. So x squared, what's 4x minus 2x? Plus 2x, good. What am I going to do with that 7 on that one side? I'm going to subtract. I got to move it over because I have a quadratic, right? So minus 8 equals 0. Okay, can I factor this? Yeah. What are the factors of negative 8? All right, so what are the factors that I can break negative 8 into that would give me a 2 when I add? Negative 2, positive 4. Agreed. So I get x equals 2 and x equals negative 4. Well, guys, in this situation, how many times do these two functions, when I graph them, intersect? Twice. Now I'm going to have two ordered pairs. So in this case, you just have to find out what each y value equals. So I'm going to say, okay, I'm going to figure out what y equals when I plug in x is 2, and I'm going to figure out what y equals when I plug in x is negative 4. Again, does it matter which equation I use? No, I'm going to use 2x minus y equals negative 1 because it's easier. That's why it's best to do it to the original. So 2x minus y, I'm going to use 2x minus y equals negative 1. So 2 times 2 minus y equals negative 1. 2 times 2 is 4, correct? Minus y equals negative 1. Subtract 4 from both sides. So negative y equals negative 5. So what's y equal? Y equals 5. So how would I write my ordered pair for this first solution point? 2, 5. And what can I do? What should I do with 2, 5 to make sure that I'm right? Plug it back in. Take 2 minutes to do that. Now on the other side, we're going to take 2x minus y equals negative 1 and plug in negative 4. So 2 times negative 4 minus y equals negative 1. So negative 8 minus y equals negative 1. Add 8 to both sides. So negative y equals 8. So what's y equal?
7.
What kind of 7? Negative 7. Good. So then my ordered pair is negative 4, comma, negative 7. Now just say you forgot that negative. You guys would write the ordered pair as negative 4, 7 and move on. But if you took a second to go back and check, would you easily be able to find your mistake? Mm-hmm. Yes, I would do that. You will, guys, have cases where your answer, and we'll talk more about this tomorrow, is either no solution or infinite many, meaning it's the same line, and I'll explain that tomorrow. But when you have a no solution case with elimination, you get a statement that's untrue, like 0 equals 12, and then you go, oh, okay, no solution. When you have a substitution no solution case, a lot of times things won't factor and stuff like that. So look at these two equations, okay? First of all, which equation would be easier to manipulate so just one variable is by itself? The top, agreed? Okay. The top one, right? Which variable do you want to solve for, x or y? Y. Y would be easiest because it's already positive. But again, if you wanted to solve for x, it's fine. So if I want to isolate y, what would I do with x? I'd plus, you're right. 4 plus x. Can I write that as x plus 4? Yeah, doesn't matter. When you're adding, it doesn't matter. I'm going to write as x plus 4 just because I like the way it looks better. But again, it doesn't matter. So that means I'm going to take this value and plug it in right here. Is everybody with me? You guys are doing a great job. So x squared, use my favorite color, x squared plus, instead of y, I'm going to put x plus 4. How come I don't need to put that in parentheses? Because it's a pause. I'm adding. I mean, you could if you wanted to. No big deal. So I have x squared. What am I going to do with that 3? I'm going to subtract it, right? I'd move it over because I have a quadratic. So plus x plus 1 equals 0. Are there factors of positive 1 that'll multiply to give me 1 but add to give me 1? No, you'd have to use the quadratic formula. And if you use the quadratic formula, guys, it would come out to an imaginary number. Can you graph a systems of equations with an imaginary solution? No, so your answer here would be no solution. If something doesn't factor, your answer is going to be no solution. Now, in a second, I'm going to do a problem where the answer turns out kind of gross, but it works. In this case, you can't get a real solution. Okay, moving along, guys. Here is a word problem. This is a very typical word problem that you will see. You are going to have word problems, so let's not just complain and say, I don't want to do a word problem. Yes, you do. We're going to do them. So let's read this, and you guys are going to see how simple this really is if you just take your time, okay? It says a total of $12,000 is invested into 2 funds. How many different accounts are there? 2. What letters could we use for 2 different funds? Agreed. I can say X and Y. What is the total amount of money that this person invested? $1,200. Well, what did I have to do to that X and the Y to get $1,200? Did I add them or subtract them? You added them. Fantastic. All right. Then it says that they tell you about the funds. One is 9% and one is 11%.
Can we just pick?
You just pick. It doesn't matter. If Audrey does Y is the 9% and Sarah does X is the 9%, you'll still get the same answer. But I can't use a percent in my equation. How would I write that? Okay, so I'm going to say that the X fund is 0.09, okay? And I'm going to say that the Y fund is 0.11%. Well, how much of the interest did I accrue or did I earn? What does it say? 1,180. Do you see how I kept the interest of 1,100 with the fund interest rate? Okay, now, when you get to an equation like this, after tomorrow, you can solve however you want, elimination, substitution. But right now, we're going to do it substitution. But if you guys notice, there's decimals in here. You're going to have your calculators. If you don't want to work with decimals, that's fine. How could I get rid of the decimals in my second equation? Multiply everything by what? 100. So when I multiplied the whole thing by 100, this would become 9x. This would become 11y, correct? And this would just become 118,000, right? You absolutely can do that if you guys are more comfortable. You'll still get the same answer. I'm just going to leave it as you'll still get this. It'll work itself out because you multiplied the entire thing. As long as you do the same thing to everything in the equation, left hand and right hand side, you're good. But I'm just going to leave it like this. We're going to use substitution. We're going to solve one of the equations for one specific variable. Which equation would be easier to manipulate so one of the variables is by itself? The top. What do you guys want to solve for, X or Y? Want to solve for X? Okay. So if I'm going to solve for X, what am I going to do with Y? Okay, we're going to subtract. I'm going to subtract the Y from both sides. So do you guys agree that this equation now says X equals 12,000 minus Y? Okay. So I'm going to take this value and plug it in right here. Now here's where your calculators come in handy. So work this with me. I have 0.09 times 12,000 minus Y. plus 0.11y equals 1180. So when we distribute, what is 0.09 times 12,000? 1,080. Okay. Minus 0.09y plus 0.11y equals, I'm looking at, I said 1,080 and I wrote 1180. Right? Okay. So now what do? Can I combine here? Okay. So 1080 minus what? 0.02y equals 1180. Agreed? Okay, so now what?
Combine like 10.
Well, we just did that, so now what?
Well, can you subtract 1080, 1080? Like on both sides?
You mean, okay, so move
Yeah.
from one side to the other. They're not like terms because they're on opposite sides. I knew what you meant though. So negative 0.02y equals what? 100. This is not negative right here, guys. Yeah, this is positive, right?
I did it different.
You did it different, and that's okay. That's okay.
I'm getting it different.
Okay, we'll look at, hold on one second, Audrey. You see how this should be positive here, guys? So divide by 0.02. And what does y equal?
10,000.
It equals 5,000. So I found out that y equals 5,000. So if I had to answer that in a real world situation, you guys would tell me that $5,000 was invested at what percentage rate? What did you make y?
Me?
0.12.
Anybody, what did you make y?
11.
11%, at 11%. So how much did you invest at the 9%?
The rest of the money.
Okay, so you should be able to figure that out. If 12,000 was the whole investment and 5 of it is in one account, how much is in the other account? 7,000. You could go back to your original x plus y equals 12,000 and say, okay, well, 12. All right, moving along. Moving along. Your guys are going to have a question or two on WebAssign, and it's going to talk about the break-even point. In business, when you break even, your cost and your revenue or your profit are what? When you break even? The same. You're looking for the equilibrium point. What do you think the equilibrium point is when something is what? Equal. Good. So when they talk about a break-even point or an equilibrium point, they're telling you, hey, take the two equations and set them equal to 0. So in this question, I left the solution here so you guys could see it, like how to set it up. But if a small business takes $10,000 and invests it, that's a cost, correct? It's coming out of your pocket. And it costs 65 cents per bottle to produce something. That's a cost. So that's where this 0.65x, x is the bottles, plus 1,000. That's what this person has invested. Their revenue is what they make. It's $1.20 per bottle. So if I want to know the break-even point between these two things, what do I do with those two equations? I'm going to set them equal to 0. I'm sorry, set them equal to each other. So I have 0.65x plus 10,000 equals 1.20x. It's how many bottles do I need to produce in order for me to break even? I don't lose money, but I don't make money. So I would just subtract 0.65x from both sides. I have 10,000 equals 0.55x, correct? Divide both sides by 0.55. And x equals what? Let's do this in our calculator. 10,000 divided by 0.55. And y'all should get 18,181.8181, right? Now, this is a real world problem. We're talking about the amount of bottles that I have to produce. How many bottles would I have to produce for me to quote unquote break even? 18,182. Can you make 0.8 of a bottle?
You round
So you round up. You'd have to make an extra full bottle. If you only make 18,181, you don't break even. You're a little less. If you guys look here, this is another one where elimination is not a possibility. Cannot use elimination. We have to use substitution. So which equation would be easier to manipulate to get one variable all by itself? The first one. What are you going to try and get all by itself? Okay, let's get y all by itself. So we're going to subtract 5x. I agree with you, Lefty. So minus 5x. So I'm going to take this value, plug it in right there, correct?
Yeah.
Okay. So x cubed minus 7 plus 7 minus 5x equals 0. Okay, we're back to basic algebra. What happens to my 7s? They cancel. I'm left with x cubed minus 5x equals 0. Now remember, it's no solution if you can't factor. When you factor, what do you look for first? The GCF. Is there a GCF here? Yes, you can take out an x, guys. Come on. So then I'm left with x squared minus 5 equals 0. Can you solve these two? Absolutely. X equals 0. X squared minus 5 equals 0. So here I have x squared equals, when I move 5 over, it becomes positive. And then how do I get x all by itself? So I have x equals plus or minus the square root of 5. How many solutions do I have here? 3. So I'm going to now find all 3 solution points. So I'm going to say x equals 0. I'm going to plug it into one of my equations. Which one would be easier to plug into? 5x plus y equals 7. So 5 times 0 plus y equals 7. What does y equal? So what's your ordered pair here? 0, 7. Perfect.
You can use any of the x's.
Mm-hmm.
So like if I wanted to.
This next one, you just do the exact same thing. I'm going to plug in x equals the positive square root of 5, and then x equals the negative square root of 5. All right, when I plug in, I'm going to use 5x plus y equals 7. So 5 times the square root of 5 plus y equals 7. Well, how do I get y by itself? No. This whole thing. What do I have to do? How do I get it to move to the other side? I subtract it. So out of y equals 7 minus 5 root 5. Can I break that down or anything anymore? No, that's it. So this solution is when I plug in the square root of 5, I get out 7 minus 5 root 5. Is that a beautiful place on the graph? No.
Yeah.
It is a specific, that is on a graph. It's just not beautiful, but it's there. And then we would do the same thing over here. You plug in negative. This would become, I'm getting ahead of myself. So 5 times negative root 5. Nah.
That would be imaginary.
Yep.
So we have to do all 3 to
You have to have 3 solutions. Yeah. If there's 3 x's, you got to have 3 y's. So this would be y equals 7 plus 5 root 5. So your x value is negative square root of 5. Your y value would be 7 plus 5 root 5. Again, I'm not asking you to graph these, but algebraically you should be able to figure out all of these out. Move on to the last one of one. All right. When you come to a problem like this, guys, there's a reason I did this problem. Come on, one more. There's a reason I did this problem. First thing, you will have problems that have fractions, but you don't have to work with them inside of the problem itself. You guys can work with these problems to where you don't have any fractions whatsoever. If you don't mind fractions, then fine. But if you look at this problem and say, ooh, I don't like these fractions. Now, another thing I want to bring to your attention. Say you have, you come out with an answer of 13 over 3, right? 13 over 3. That would be 4.3333. Is that a terminating decimal? No. If you get an answer that is a fraction, and you try and turn it into a decimal, and it's a repeating decimal, you have to keep the fraction. You cannot use approximations with your decimals. Just make sure you guys understand that. But we can do something in each of these equations to get rid of the denominators. Right? You do not all have to multiply by the same number. But is there a number that you guys can think of that you could multiply this entire fraction by that would eliminate all of the denominators? 4. You could use 8. You could use, anything that's divisible. If I took 4 and I multiplied here, here, and here, because what you do to one side of the equation, you have to do the other. When I multiply 4 times 1/2, it becomes 4 over 2, which becomes what? 2x. When I multiply 4 times 3 over 4, what do the 4's do? They cancel out, so I have plus 3y equals what? 41. All that's going to happen when you do this is your numbers get a little bigger, but you will eliminate the fractions, which is perfectly fine. What about here? What would I multiply the entire equation by? You could do 12 if you wanted to, because everything is divisible, but that's fine. But I'm going to just do 4 because it's easier, smaller numbers. But again, you could use 4, you could use 8, you could use 16, whatever. So what happens here with my 4 times 3/4? Becomes 3x minus what? 4y equals 16. So here is a case, guys, and I'm bringing you into tomorrow's lesson. Here is a case where would substitution be beneficial for you guys no. When you use substitution, you're trying to isolate one variable. So you would have to isolate a variable to where you'd have to divide by a fraction. It would just be gross. So in this case, substitution would not work. Elimination would be your best bet. You have a question about this?
I do.
What's up?
If you multiply the top by 4, do you multiply the bottom by 4?
No. Good question. You don't have to multiply by the same thing as long as you do the same thing throughout one equation. Like if you had decimals and the top one you did by 10 and the bottom one you multiply by 1,000, that's fine. These two don't have to be the same. It just has to be constant throughout.
So we don't use substitution?
Here, I would not use substitution, no. I mean, you could. It would just be horrific. Here, we would use elimination. Let's do a little review of elimination. What would you try and eliminate here? Doesn't matter. X's or Y's? Okay, X. If I was going to eliminate my X's, that means my coefficients have to be exact opposites. You could, me personally, I always do X's. I don't know why. But you could do Y, it doesn't matter. But you have to get the coefficients to be exact opposites. So what would I have to multiply the top equation by and the bottom equation by for them to become exact opposites? Okay, you want to do the top by 3 and the bottom by -2? Okay, that'll work. So when we do this, we're gonna distribute all the way through. What you do to one side, you do to the other. So 3 times 2 would be 6x. 3 times 3 would be plus 9y. And then 3 times 41 is what? 1, 2, 3. Good. And then on the bottom, -2 times 3 is -6x. -2 times -4 is plus 8y. And then -2 times 16 is -32. So when we eliminate, guys, we add down. What happens with positive 6x and negative 6x? It cancels. What's 9 plus 8? 17y equals, what's 123 minus 32? Negative 90, or positive 91, my bad. And then how do I get y by itself? Divide by 17. When you divide y equals, what's 91 divided by 17? Ooh, 5.352941176. Can I use that decimal? No, I have to leave this as 91 over 17. And then how do I find out what x is? You plug it back in. Is that going to be wonderfully beautiful to do? No. I'm not saying you're going to have a bunch of these, but the possibility of having to use fractions is on the table. Everyone understand that. Please understand that. If your fraction reduces to a terminating decimal, by all means, go ahead and do it. But if your problem starts off with fractions, your answer should be in fractions. If it starts off in decimals, it should be in decimals. Does that make sense? What's up?
Are we using calculators for this?
Yep.